These are the notes for Algebra 2, Section 7.4, Part 1. We're looking at evaluating logarithms. Now, logarithms are something you've probably not heard of up to this point, and that's okay. Basically, a logarithm is an inverse of an exponential. All right, logarithms are inverses of exponentials. So, if I had b to the x power equals y, whatever those numbers happen to be, then the logarithm of y with base b is written as this. We have log base b of y equals x. Now what you should notice is these numbers are basically, or these letters are basically the same, they're just reorganized. And we're going to see a little bit later the kind of why this happens and what's going on with that. But for now, we just want to sort of memorize the definition of a logarithm and some basic evaluation techniques. So we have a logarithm. Let's break this down just a little bit. If I have b to the x equals y, that is, I have something with base b and exponent x, then that equals some number. The logarithm tells me that if I have the logarithm of base b, so instead of the exponent of base b, I have the logarithm of base b of y, that equals x. So instead of equaling y, it equals x. So it's like we turn the whole thing on its head. What that does for us is it will allow us to solve an exponential equation for y, and that's going to be very useful later on. Now, changing between exponential and logarithmic forms is really simple. All we have to do is rearrange the numbers, and that's because the bx equals y, b to the x equals y, and log base b of y equals x all contain b, x, and y. As you can see, this b is the base, this y is over here, and the x is there. Right? So these numbers just get moved around. And what happens is that if we have a true equation here, when we rearrange our numbers, we should end up with the true equation over here, because the numbers haven't changed. So, with that in mind, if I have log base 2 of 32 equaling 5, I rearrange the numbers. Remember, this is b, this is y, and this is x, right? Log base b of y equals x. Then I would rewrite this as 2, base 2, to the 5th power, to the x power, equals y, in this case 32. And that says that 2 to the 5th equals 32, which is true. 2 to the 5th does equal 32. If I have log base 7 of 1 equals 0, same idea. The base is 7, right? The base of the exponent and the base of the log are both 7. We raise 7 to the 0th power because x is 0, and that should equal y, which is 1. And it's true, 7 to the 0th power does equal 1. Here I have log base 13 of 13 equaling 1. So that means that we have a base of 13, we have a power of 1, and we have it equaling 13, which again is true. 13 to the 1st power equals 13. My base here is 1/2, log base 1/2 of 2 equals -1. So my exponent is -1, and it equals 2, which is true. You might not be used to thinking of it, but of course when we have a negative exponent, we take the reciprocal, and the reciprocal of 1/2 is 2. Alright, moving on. A couple more definitions for you. We have the common logarithm, which is basically a logarithm with the base of 10. The thing that's special about the common logarithm is that it will just be written as log. There won't be a base anywhere. So it would be log of x or log of whatever. No base will be here. The natural logarithm has a base of e, and that one is denoted by ln. So if I have log with no number, that's log base 10. If I have ln, that's natural logarithm with the base of e. The plus side of both of these is that these are both buttons on your calculator. So evaluating these is real simple. You press log, you type the number in, you hit enter, you get an answer. So those are easy. Some logarithms can be solved by asking yourself what power of b, remember we have log base b of y equals x, and if we wanted to solve for x or evaluate this, we would ask what power of b gives you y. What power of b gives you y? That is the question you would want to ask yourself. And asking that question, you can evaluate a lot of logarithms. Let's look at a few. For instance, if I wanted to evaluate log base 3 of 81, I would ask myself, alright, self, 3 to what power gives me 81? And the answer to that is 4. 3 to the 4th power is 81. 4 to what power gives me 0.25? And 0.25, if you're not aware of it, is 1/4. So I'm going to erase 0.25 here and put 1/4. So again, I ask myself, what power, log base 4 of 0.25, what power do I raise 4 to get it to become 1/4? And the answer to that is -1, because we took the reciprocal. 4 to the negative first power is 1/4. So the log base 4 of 0.25 is -1. Do a couple more of these. Here I have log base 1/4 of 256. So again, I ask myself, what power do I raise 1/4 to get it equal to 256? And in order to figure that out, keep in mind, of course, that we are taking the reciprocal because this is a fraction and our answer is a whole number. So we know it has to be negative. And in fact, if we raise 4 to the 4th power, we get 256. 1/4 to the negative 4th power is 256. If I have log base 49 of 7, right, what power do I raise 49 to get 7? Well, we know that 7 is the square root of 49, right? Well, if 7 is the square root of 49, then that would be raising 49 to the 1/2 power. That means that log base 49 of 7 is 1/2. So we can evaluate a lot of logarithms. Now, I know I sort of went through these kind of quick, and that's okay. I'm used to these numbers. If you're not used to these numbers, they can get kind of tricky. But using the calculator and a little bit of trial and error, it is possible to come up with all of these answers. And of course, the more of these that you do, the better you get at it, and the quicker it will go.